Hello everyone, welcome to our webinar, Challenges in Modern Pig Production, Solution from Nordics. I'm Dr. Shah Hasan, Area Sales Manager at Hankkija Finished Feed Innovation. The format of today's webinar will be three main presentations, each of 30 minutes, with 5 minutes questioning at the end of each presentation. I will summarize at the end with a short presentation. Please send your question as soon as presentation begin. In modern pig production, gestation or transition and lactation feeding and management is an important topic on discussion. Sow undergoes a significant metabolic, hormonal, behavioral changes which often lead to a higher piglet mortality during and after farrowing. The large litter of the sows are always mixed with a small underweighted piglets, which has a higher mortality and slower growth rate. However, hyperprolific sows are often suffering from an exceptionally longer farrowing duration, which is detrimental to both sow and piglets. Apart from maternal feeding and neonatal death, post-weaning is also a critical period in piglet life. Dietary changes, immature immune and intestinal system, and pathogen load endanger the integrity of the intestinal wall and resulting post-weaning diarrhea. Today we have our speaker, Professor Filip van Immerseel from University of Ghent, Belgium. Professor Filip will be talking about the gut integrity and how resin acid in the monogastric diet helps to strengthen the intestinal barrier. We have our second speaker, Dr. Peter Theil from University of Aarhus, Denmark. We'll look at the late gestation feeding of sow and impact on the farrowing process and neonatal survival. Our third speaker, Dr. Claudio Oliviero from University of Helsinki, Finland. Dr. Oliviero will focus on management strategies and in late gestation to alleviate farrowing stress in hyperprolific sow and thereby improving neonatal survivability and immunity. At the end, I myself will give a brief presentation on the benefit of Progres, a novel innovation from Hankkija Finished Feed Innovation, and its application in sow-led gestation diet and lactation feeding. We will have a short break of 5 minutes after our second presentation by Dr. Theil. Okay, let's kick off the webinar with a short introduction of Hankkija Finished Feed Innovation by our export director, Jyrki Heinimo. And after that, we will move to our first speaker, Dr. Filip.
Okay, good morning, good day, good afternoon, everybody. My name is Jyrki Heinimo. I've started as export director for Hankkija Finished Feed Innovations in the beginning of this year. And it's really been an exciting start for my career with Hankkija, not only to struggle with the coronavirus, but especially to learn about new innovations and the products that Hankkija is offering. Many of you know that Hankkija formerly was known as Suomen Rehu, and we are really strongly building on that heritage. As Suomen Rehu has had and thus Hankkija, we have had a long tradition in innovation, having a really strong focus on natural solutions in feed additives. We have brought to the market new feed enzymes earlier called Avizyme or Porzyme, and later on developed the Progut yeast hydrolysate in the early 2000s. And now today's topic, Progres, which we brought to market several years ago as a completely new innovation on the feed market and feed additive market. Hankkija as a company is the largest agribusiness company in Finland. We have about an 800 million euro turnover. And we are also the largest feed manufacturer in Finland with about 40% market share on the domestic market here. This history and background really give us an excellent basis to develop and support our current and new innovations for the feed additive market. We are really very proud of our achievements and the products that we have developed. And it's really great now that we can have this wide audience in today's webinar to hear more about the Progres and its applications in poultry, as an example, and then especially in sow diets. So as we draw from the Finnish experience and nature, this is really the backbone of our thinking and our development. And we are also working on several new projects to bring some new innovations on the market, but we will get back to those later on when those come more real. With these words, I really want to wish everybody very welcome to this webinar. I hope you enjoy it. Please be active, post your questions on the question site, and those will be then reverted by Shah Hasan at the end of each presentation. Welcome everybody, and with this I'll give the word to Filip van Immerseel. So Filip, please go ahead. Thank you very much.
Okay, thank you very much for the introduction. I hope you can all hear me well and see the screen. So basically I will talk about a little bit of a different animal species than what the webinar is mostly about. So I will use the broiler chicken model to show how resin acids can potentially affect intestinal health. But actually the data that I will show, or the principles I will show, that really is also present, of course, in pigs, even in ruminants. So it's really a little bit of an animal species independent mechanism I want to clarify a bit. But we, as a university here, work a lot with chickens, so that's why I based my examples on the broiler chicken. So in the first slide, just as a matter of introduction, I just want to put this on here as this is explaining a bit why we should develop solutions for gut health. And on the left side, these are just data showing you the periods in life of a broiler chicken when most antimicrobials are used. So you see, for example, that the early post-hatch period, a lot of companies, broiler farms start using antimicrobials. And the second critical period is around the 3 to 4 weeks of age. On the right side, you see the same data more or less for pigs, which is, of course, just showing you that the postnatal period, the post-weaning period, and also the transition period from the weaning to the grower store are the periods of life in the animal in which you have high peaks of antimicrobial usage. And if you look at the causes of the antimicrobial usage, you will see that about 70% of the antimicrobials are actually being used for intestinal problems. On the left side, there's a clear need for antimicrobials for what we call dysbiosis, for necrotic enteritis. I will come to this in a few minutes, but also in piglets, of course, enteric problems in the early postnatal period, and of course, post-weaning diarrhea are critical causes of antimicrobial usage. So to just take off this presentation, of course, we need to know what a normal gut is. Actually, when you want to repair a certain lesion, you of course need to know what a normal gut looks like. On the left side, you see some epithelial cells. I just show here the epithelial lining. And what you normally have in the gut of an animal is a very diverse microflora that is able to carry out quite a variety of functions. On the right side, well, this is how a normal gut should look like. And of course, the histology picture there is just giving you you see very long, slender villi, thin villi, so that means a lot of epithelial surface that can be used for absorption of nutrients. Now, I just go into the most devastating or the most significant disease here that can occur in the gut of chickens, of broiler chickens, which is necrotic enteritis. And this is caused by Clostridium perfringens, a pathogen that is always also, of course, present in the piglet gut. But what you see here is just left on top. This is a histology picture of a villous surface. You see, if you look very well, some bacteria here left on top. Going further to the second histology picture, you see a lot of bacteria colonizing the mucus. And then the third picture is very important, because what happens there is that you see a breach in the intestinal epithelial lining. You see an epithelial cell that is still off. I think some people are still unmuted. Maybe we should mute the microphones, please. So you see some epithelial cells there being killed, and of course that's when you have a lot of leakage of proteins into the intestinal tract, to which this Clostridium perfringens can start using as a substrate for proliferation, and then you get this very strong necrosis that is induced by the bacterium. So this initial damage to the epithelial layer can be caused by coccidiosis, by mycotoxins, by viruses, even by any trigger that harms the intestinal epithelial lining. And this is, of course, very crucial, because it means that if you don't have this initial gap in the intestinal epithelial lining, you will never develop this disease. So there are other factors that are predisposing here that affect the integrity of the intestinal layer, and then Clostridium can cause some problems. So this is what it looks like. You get some defects in the epithelium, and then of course you have this expansion of the red bacteria, which is Clostridium. Now, second major problem in broiler chickens is what we call, or what is called by veterinarians, dysbiosis, which is a very vague term, very difficult term in fact. But this just points to inflammation of the intestinal tract without really a clear etiology. And that causes, of course, increases in feed conversion, problems with body weight gain, etc. So this has economical consequences. What you see on the left is an inflamed gut, and what you see on the histology picture are thick, shorter villi with a lot of brown dots, and all these brown dots, these are in fact lymphocytes. So this means that there's a lot of immune cell infiltration there, and this is clearly pointing to an inflammation in the in the intestinal wall. So this is costing a lot of energy to the animals that cannot be used for growth. So this is a very important problem there. Any pathogen that enters the mucosa can cause this inflammatory phenotype. So this is a bit how it looks like. Left, as I already mentioned, this is the normal condition. So you have this highly diverse microflora, these very tightly sealed intestinal epithelial cells. So you have the tight junctions, which are these red, depicted by these red horizontal lines here that connect epithelial cells with each other. In cases of this dysbiosis state, you see some defects in these tight junctions, and then you have some bacteria that can leak through and end up at the basolateral surface of the epithelial cells. And when that happens, these bacteria can bind to some receptors at the epithelial cells, and these trigger cytokine production and inflammatory cell influx in the mucosal wall. And that's what you see there, of course, right below in the histology picture, a lot of immune cells that infiltrate the mucosa. And then a final example of why intestinal integrity is important. I already mentioned necrosis, I already mentioned inflammation, but also you have quite some bacteria that can translocate to the bloodstream when the intestinal integrity is disturbed, when you have an increased permeability. And a very well-known example in broiler chickens are osteomyelitis and chondronecrosis with osteomyelitis, and also, of course, a lot of different kinds of septicemic conditions. Meaning that, for example, on the right side, you see some liver inflammation, hepatitis, and you can isolate bacteria from that initially come from the gut. On the left side, you see very typical conditions that cause lameness in broilers, necrosis of the femur, the tibia, or even the vertebrae. And if you isolate bacteria there, you will isolate E. coli, enterococci, etc. So clearly gut inhabitants that leak through the intestinal epithelial layer and end up at different organs. This is a very important cause as well of antimicrobial usage. And if you look at this epithelial permeability, I already mentioned that it's important because if you have an increased epithelial permeability, you get inflammation, bacterial translocation, and gut damage. Also, this is very well related with performance. What you see here on the left is just a study that we have been doing in experimental conditions, and in which we have been linking villus length with body weight, just showing that if you have an increased villus length, the animals will be more heavy, will have digested more material, of course, and absorbed much more material. So there's a clear link between villus length and body weight, which is also reflected in field conditions. That's what you see on the right side. Each dot is just the mean value of number of animals for a farm. So this is what you actually see. So epithelial permeability is very crucial because that leads to villus shortening and, of course, leads to performance losses. So one of the big questions, of course, is how can we normalize that? Left on top here, this is what I call dysbiosis. Right on top, this is gut necrosis caused by Clostridium. And below, of course, you see the normal condition. One of the key questions is, if we have a normal gut, can we use compounds to prevent that we run into left on top or right on top, that we run into these problems? Or if we have this kind of dysbiosis state, can we revert it back to the normal condition? And of course, we all know that antimicrobials can help here in certain circumstances, and when the animals are really diseased, you need to do that. But of course, we want to use other solutions to have this normal condition and have this optimal animal performance. And that's, of course, when we come into supporting intestinal health using feed additives. In fact, what we need is products or compounds that support intestinal epithelial integrity. As simple as that. Of course, you also have products that produce that are antimicrobial or produce, or maybe probiotics that produce antimicrobial compounds. But basically, there are a lot of novel things that are being developed that are really focusing on effects on the host, meaning that compounds that have an effect on the inflammation, that are anti-inflammatory, because they support the epithelial integrity, and they are designed as such that bacteria are less capable to leak through the epithelial lining and cause this hyperinflammation in the intestinal tract that is causing performance problems. Now, we all know about the classical list of feed additives. I think we all have been working quite a lot on these. We have been doing a lot of trials with acids, prebiotics, probiotics, and many different kinds of products, of course, and quite a lot of these can affect also epithelial integrity. Some of them because they also act through the modulation of the microflora, which is also a reasonable way to work, of course. But one of the important things that have never been looked into, and we have been doing quite some studies recently with resin acids, because these seem to affect what happens with the basement membrane. And what is the basement membrane? Well, in fact, what you see here is, again, the epithelial cells that are connected or sealed with these intercellular junctions, these tight junctions. You have the microflora on top. And the basement membrane is, in fact, a layer of different kinds of extracellular matrix proteins, mostly collagen type 4. And collagen type 4 is creating here like a surface to which the epithelial cells can attach. And when you have a defect in this basement membrane, it means that the epithelial cells can just be disconnected, and you can have a release there and a gap. So this basement membrane is also very important. The structure of this basement membrane is in fact produced by different types of fibroblasts. And also there are a lot of different enzymes that can either cut this basement membrane or try to connect different components of this basement membrane. So, but this is a very important element in epithelial integrity. And when we started working on resin acids, well, this is just a slide I took from Hankkija. This is just showing, but some data on what happens when in different studies at different places in the world when resin acids are actually added to poultry diets. So what you see here on top is increases in growth rate, so in body weight gain, and below decreases in feed conversion ratio. So this is quite nice. What we were asked as a university some years ago is to try to figure out what actually is driving these performance effects. So we did quite some studies with resin acids, both in vitro but also in vivo, adding resin acids to the diet and looking in the intestinal tract what actually was going on there. And as I just mentioned, we focused on this epithelial integrity and also on the structure of the basement membrane. Now, what are resin acids? Well, these are these diterpenoic structures here, these aromatic structures. The most important one is abietic acid, but you also have some variants such as dehydroabietic acid and some related components. I'm not going to talk too much about this. I guess other people will do that at the end of the day here. Now, one of the interesting things when we started working on these compounds are some data that we found into the literature. If you look at the literature, these abietic acids and also other of these resin acids, they are actually described as being very much involved in wound healing. What you see here, for example, in the middle is a paper in which wounds were created on the skin of mice, and you see in control conditions that it heals after some days, after 8 days, it's going back to normal. But when abietic acid is added there on this wound, you see that wound healing is going much faster. And this is interesting, of course, because this again gives you at least an indication that the effect of these resin acids here have to do something with anti-inflammatory activity or with an improve in epithelial, well, in cell proliferation or in trying to seal gaps. Left on top, it's maybe a bit difficult to see, but what is mentioned here is that if you take cell culture plates, you add cells in a dish, you let them grow, and you scratch in these cell layers to make some kind of a breach, that if you add abietic acid at different concentrations to the medium, you see that these cells are growing much faster to each other, and also the scratch or the gap in between the epithelial cell structure, the cell structures are sealed much more much faster. That's exactly what the left on top is saying, and on the right side, I'm not going to focus too much in detail, but you have some papers that also clearly say that resin acids are actually activating a transcription factor in epithelial cells and in other cell types, which is called PPAR-gamma, and PPAR-gamma is in fact the major contributor to anti-inflammatory effects in the intestinal epithelial cells and the intestinal tract. So it's just some literature data showing that there are quite some effects to be expected from these resin acids. We have done studies in broilers. This is just one study that is published in Veterinary Research. Right on top, you see the paper, you can look at it there. But what we have seen is that if you give resin acids, which is basically at 2 kilograms per ton to just healthy broilers, that even then you see quite an effect on lymphocyte infiltration in the intestinal wall. Left, you see data from the duodenum. Right, you see data from the ileum. And we quantify it by measuring numbers of cells per millimeter square. But you see very clearly the difference in the histology pictures. This here on the left is a control duodenum with a lot of inflammatory cells. And in the middle, you see that the numbers of brown dots of inflammatory cells in the intestinal tract are actually very much reduced in both the duodenum and ileum. It's very clearly seen on the histology pictures. We didn't really challenge the animals here in this trial, meaning that in fast-growing broiler chickens, you always have some kind of inflammation in the gut. Just because you have an excess of nutrients available, you always have some potential or some opportunistic pathogens in there that trigger some kind of inflammatory reaction. So this is something we often see when we use samples derived from the field. You always see some kind of background inflammation if you cut a section of the gut of a broiler chicken. This is more or less, it's not normal, but it's a normal state in the broiler industry. So you can actually reduce inflammation using resin acids. Why is this the case? Well, if you take samples from the intestinal tract and you measure and you make an extract there and you add it to gelatin or to different types of collagen, you will see that the intestinal tract or the extracts of the intestinal tract derived of chickens that received resin acids. This is called RAC here. They actually, if you add these different extracellular matrix proteins, you see that the breakdown of collagen type 4, collagen type 1, and gelatin is actually much less. So this means that in the intestinal tract of these animals that are given resin acid supplements, that there's, well, in normal conditions and definitely under inflamed conditions, you have this matrix proteinases that break down different types of collagens. If you add resin acids to the diet, this is going to be reduced quite a lot. So this is just some basic information, but if you look at the enzymes that are catalyzing this collagen type 4 breakdown, for example, and as I mentioned, collagen type 4 is the major protein present in the basal membrane, so this is quite, this makes sense. It means that in animals receiving resin acids, you have less basement membrane breakdown, so a higher epithelial integrity and thus less inflammation, of course. If you look into the enzymes on itself, there are quite some papers that, well, mention matrix metalloproteinases as being very much involved in inflammation. So what you can see, for example, in publications on human inflammation is that these matrix metalloproteinases that are breaking down this basal membrane, for example, or breaking down the structure of the intestine, they're very important here. I just go to the left side there. What you see there, in fact, is expression. This is a gel in which we have poured gelatin. So everything in black is just a gel with gelatin. If you extract proteins from the intestinal mucosal tissue from animals that either were given a control diet or a resin acid supplement diet, you see that these white bonds here that you see left, some of them actually disappeared. And that means that for some reason, resin acids, they actually reduce some, well, expression of specific matrix metalloproteinases in the intestinal tract. And that makes sense because, as I just mentioned, this means that you will have less breakdown of this basal membrane and a better intestinal integrity. Final slide before I wrap up here. We have been doing quite some in vivo modeling in which we try to induce inflammatory status in the intestinal tract of animals. You can do that with pathogens, for example, in necrotic enteritis models, but you can also do that with diet-induced inflammatory models, and there are a variety of models to do that. What I show here is just one experimental trial in which we have been using poorly digestible diets to induce some kind of dysbiotic state. What you see here, I don't show you all the data, but if you would look at the histology slides of this kind of models, you would see inflammation, villus shortening, and a lot of different other things you expect in an inflammatory gut, in a gut with excessive inflammation. You also see here that, of course, this is clearly affecting performance. So this is just a model in which you induce the inflammation. This is leading to performance problems in these broilers, actually an increase in feed conversion. What you also see here is that if you use this kind of challenge models, that collagen type 1 and type 4 breakdown is actually increased. So again, what you see in any dysbiosis or challenge model with a pathogen or with a poorly digestible diet or with coccidiosis, whatever, is this increase in breakdown of this basal membrane of these different types of collagen. So it means that if you can actually reduce this collagen type breakdown, and this is what I just mentioned, resin acids do that, you will actually also be able to improve performance or feed conversion in this case if you add these compounds to the diet. So it's I think it's something very powerful. It has host effects, but of course there's quite a lot of work still needs to be done. So, but I just wanted to give you the basic mechanisms or the principles of how these resin acids could work. And I took the broiler example, but you can as well use the pig or even other animal species example well, probably it will have exactly the same principles that can be applied to these other animal species. Just to wrap up, I just want to mention that I think intestinal integrity is a very crucial thing for improving gut health and for having a well-performing animal, because losses of intestinal integrity and increases in epithelial permeability is leading to inflammation, very clear. This has also a very clear link with some host enzymes, which are matrix metalloproteinases. But because these can in fact lead to collagen type 4 breakdown and to basal membrane breakdown, but resin acids affect these matrix metallic proteinase activity and thus are able to strengthen the basal membrane in the epithelial cell lining structure. Of course, we need quite a lot of other things to do. We need to confirm all of this in disease models, and this is something definitely that needs to be done in the future. I think I just showed you a different way of, let's say, there are a lot of compounds working on bacteria, suppression of bacteria, a lot of other compounds with a variety of mechanisms of actions, but I think this is something specific and novel in how certain compounds can promote intestinal health. And with this, I want to close my presentation. I would be happy to reply to questions.
Thank you very much, Filip. Thanks for your nice and insightful presentation. And obviously, I have some questions, but I will just, because of the time, I will just pick up a couple of the questions. And one of the questions from the audience is asking, can resin acid heal the gut tissue damage like it can heal the skin?
Can it heal gut tissue damage? Yes, it seems to be the case. So that's what I try to mention. So if you have a certain, well, it's actually in cases of let's say epithelial damage, you anyway get some inflammatory cascade and you get some damage to the, not only to the epithelial cells, but also to the basal membrane, often in certain cases. So the resin acids can actually stabilize this. This is what we have been showing in healthy broilers, that this is a very clear stabilizing effect here, an anti-inflammatory effect. So yes, under challenge conditions, we showed that different challenges also have the same effects, but we didn't apply resin acids to this in these different models. So this is something that still needs to be done. So, but there's a very clear and proven effect also on this. Yes.
Okay, thank you. And I have my question from me, like as a vet, like if I go to the farm and if I see like weight litter, so I mean, can I like immediately comment that you have a gut integrity problem or that your bird lost the gut integrity?
Well, if you have wet litter, if it is not coming from some whatever problems with drinking water lines, etc., wet litter means inflammation. Because wet litter, it's diarrhea, and you only can have diarrhea when you have a leakage in the intestinal epithelial lining and an inflammatory reaction. Otherwise, you never have leakage of material and diarrhea. So wet litter is in fact more or less synonymous with an inflammatory reaction in the gut.
Okay, thank you. And some of the questions is coming actually like, can resin acid also do the same mode of action of preventing collagen breakdown like type 4 in piglet? And I guess, like, I hope like it's the same way like working in the all monogastric species, isn't it?
Yeah, it is the case, because it will be also in rodents, it has been shown. So I guess this is a general, it's a universal principle that this will occur in all the different animal species. So there's no reason to think that this would not be the case. So yes, I would assume it is. We have data from chickens. There are also some data published on rodents and other types of models. So there's no reason to think that would be different in piglets or other animal species.
Okay, thank you, Filip, and we are very grateful to having you with us today in this webinar. And because of the time, of course, we are not continuing further, and I will move now to our second presentation. Dr. Peter Theil. He is an adjunct professor at the Department of Animal Science from Aarhus University, Denmark. He is researching nutritional and physiological aspects of sow, especially during transition and lactation period. Recently, some of his research has got wide range of media coverage, especially timing of the last meal and its relation to the farrowing duration, and of course the Born to Live project. Today, he will share with us his researches on less gestation feeding of sow and its impact on sow and piglet performance. Peter, looking forward to your presentation.
Thank you very much, and I hope everybody can hear me what I'm saying. So yeah, I'll talk about what I'm working with every day at Folum, late gestation feeding, and how that translate into piglet performance, and how we can actually improve the performance of sows and piglets by changing the diets. So today I'll talk about the importance of energy at parturition, how that affects nest building, or how nest building affects the energy costs. I'll also talk about the farrowing and uterine contractions and colostrum production, all with aspects of how much energy is required by the sow. And I'll comment on or talk about why are the dietary fibers so beneficial for all of these processes. So first of all, I would like to present some mathematical model we have been working on to illustrate that there are quite some changes around farrowing. We have farrowing here as at day 0. So in late gestation, we have most of the energy required by the sow is actually going to the sow body for maintenance and not much for reproduction. But when we comes into milk, into lactation, we can see the increasing milk production really takes a lot of energy. And if we look into the transition period, which I have marked with black here, we can clearly see before the transition period, there's not much change from day to day. And after the transition period, we are almost having a constant energy requirement for the milk production, even though we do see some changes from day 7 to until weaning, but not much. Everything what really changes in the transition period, which I defined from 1 week before parturition until 1 week after parturition, that is where everything really changes dramatically day by day. And some of the things that changes is the colostrum is being produced. We have nest building activity. We have a farrowing sow, and then initially we have the milk production, which increases dramatically day by day in the first week of lactation. So what is required when we talk about a sow that approaches the farrowing? I have mentioned it, nest building. She stands up a lot, she raises up and lay down, she bites in the railings, she is digging in the concrete and doing a lot of stereotypic behavior because she is not really able to build a nest. Everything here costs energy. Physical activity is demanding. Uterine contractions are demanding as well, and I'll come back to that. Everybody that has tried to give birth assistance to sows, they have experienced how strong these uterine contractions they are. So for sure energy is required here as well. And then we have the colostrum production, which also takes quite a lot of energy. And I'll come back to why it's very high demand actually at the day of the farrowing. Let's start with the nest building activity. This is data from my PhD study, and you can see here on those black lines here, they represent the physical activity measured by a photocell. So here the sows are standing when it's high, and when it's low here, sows are laying down. And here we maybe have a peak where they have been standing for 1 minute, maybe they have been sitting. We can't distinguish those two, but it's very, very easy to see. We have recorded the heat production of the sows. That's the red ones here. And it's very easy to see as long as the sow is laying down, it follows a slight diurnal pattern, very low. And when they raises up here, the heat production immediately doubles. So very, very instantaneously, we see a doubling in heat production when the sow changes posture from laying down to standing. What can we do with this nest building activity? Well, we can give them some straw. They are really, you can call them functional fibers. They are good for rooting material. It's also really good for nest building. But for some reasons, it seems like farmers are not really keen on providing straw to sows. it can prevent can give some manure problems and so on. But they are really good for the sows, that's for sure. The thing with the straw is they don't contribute at all with energy, but maybe they do in a way, because if we can make sows more calm, they will spare some energy which can be used for colostrum production or the farrowing process if it was not spent for physical activity. This is from a Dutch study carried out by Martin Reinen and co-workers, and they showed that if we feed more sugar beet pulp to sows during gestation, we can actually reduce the standing activity of these sows. So giving 0 or 10% fiber from sugar beet pulp, sows were standing 3 hours and 6 minutes on average. Giving them 20 to 30%, they were standing roughly 1 hour less per day. And that really reduces the heat production and therefore the energy requirement of the pregnant sows. If we can reduce the physical activity during the nest building phase, I believe that is really something we want to go for. We actually started 5 years ago to really try to understand what happens with the farrowing. I've always regarded the number of stillborn piglets as something random, and I didn't believe we could do much about it, at least from a feeding perspectives. But I was asked to contribute with a book chapter to the book called The Gestating and Lactating Sow, edited by Chantal Farmer. And at that time, I started to really consider what happens really with the sow when she gives birth. And I could see that some of the sows were really calm throughout the entire process. Others were just giving birth very, very rapidly to all the piglets, and I was starting to consider what are the differences here. And I was focusing a lot on the last meal before parturition and what goes on from the last meal until she starts to farrow and continue throughout the farrowing. And let me explain what happens with the last meal. Consider this is the very last meal she ingests before she starts to farrow. A bit more than half of that meal is actually starch, so most of the energy is actually coming from starch, which is taken up as glucose. It is being digested and taken up a bit from the stomach as lactate, but mainly in the small intestine as glucose. And most of this energy is actually taken up, as you can see here, during the first 4 to 6 hours. So this here is before sows are fed, and now we can see how much energy is taken up already half an hour after the meal is consumed. Or actually when the sow is completing her meal, she has a maximal uptake of energy from starch, and then it declines over the next hours postprandially. And you can see after roughly 5, maybe 6 hours, then we are back to the low level before she was fed. These sows were fed 3 times a day, so every 8 hours. And you can see the increase here. The peak here is roughly 5-fold compared to that before they were fed. So we see a huge extra amount of energy coming into the blood already half an hour after. But what happens if the sow is not standing up now at 8 hours and eating the next meal that is being served because she is starting to farrow? She is not raising up and eating that meal, and that's why starch is not a really good energy source for the farrowing sow, because she's only having energy for say 5 to 6 hours. What about the fiber? Well, if we look into the meal, how much of a fiber is, how much of the energy is actually coming from fiber, we can say 8%, only 8% of the energy coming into the blood is actually originating from the fibers. So they are being they are being ingested, coming into the GI tract and in the hindgut, so in the cecum here and in the colon, it's being fermented by bacteria, and what is taking up to the blood is energy in form of short-chain fatty acids. But if we have 15% of fiber in the diet, we will only get 8% of energy coming into the blood, so quite a big loss. But I can also say we can easily increase the amount of fiber in the diet because it's not much. It takes up of space. It would be more difficult to increase the amount of starch in the diet as a percentage, but we can easily increase the amount or the percentage of fiber in the diet. Here you can see what happens. The energy uptake from fibers, or in short, chain fatty acids coming from fiber, is completely flat. We don't see these postprandial changes as we saw from the starch. And what is also clear is if we increase the amount of fiber in the diet, we simply increase the constant uptake. It takes us a few days to adapt to a new level, but we can easily serve them more fiber in late gestation, and they would find a new balance, maybe at the double amount of energy coming in from the fiber. And this is constant for at least 24 hours. That's another colleague of mine that has carried out such an experiment, showing that it's really a long-lasting energy source when we are eating fiber. And this is actually the same as you experience if you go to a McDonald's and eat a burger without any fiber. You're hungry already after, say, 2 hours. But if you take an oatmeal in the morning, you are hardly hungry after 4 or 5 hours because you are filling your hindgut with fiber and get quite a lot of energy from that location. So we really was interested in this and to understand what happens, and then we started to work on the farrowing duration and looking into, is there any relationship between the time from we feed the sow the last time before she farrow and until she starts her farrowing? And we got quite a surprise when we saw the results. These are the data from 7 different colostrum experiments. We didn't at all pay attention to the farrowing duration. We gave farrowing assistance if we felt she was in need of that, but we always had the rule that it has to be at least 90 minutes since she had her last piglet before we would assist her. So we had maybe a bit of the influence on this, but we never had any focus on the farrowing in our studies. So we were quite surprised with how big a relationship we were able to show here, and this caused us to distinguish between sows in 3 different categories. The sows that are, you could say, lucky to start the farrowing quite early after her last meal. We call them the green sow because they are not suffering from energy depletion and they are able to complete the farrowing within 4 hours on average. Those that are moderately lacking energy, that's the yellow sows. They are starting their farrowing 3 to 6 hours after being served the last meal. And the red sows, that's those that are severely lacking energy. So when we looked into the stillbirth rate of the piglets, we could easily see that the green sows, those that had enough energy, they had the lowest stillbirth rate, roughly 5%, and it was almost double in sows that were red, so those that were severely lacking energy. And again, we didn't at all pay attention to the farrowing, so we were focusing very much on the colostrum. So, but we were surprised that we were actually able to demonstrate a statistical significance based on, I believe we have 166 sows at that time. But the thing was here, we knew exactly the amount of time or the number of hours passing from the last meal until the sow was starting to farrow, which I believe is the most important trait to understand the stillbirth rate. If we looked into the birth assistance, we could also see that there was a very, very clear difference between the three categories of sows. So the green sows hardly needed any birth assistance. 0.5% of the piglets was born being assisted, and tenfold more piglets here in the red sows were born with while they were being assisted. So roughly 5% of the piglets. And this is critical from two perspectives. First of all, the farmer has to spend a lot of time putting on the glove, putting on glue, and making sure he or she is not making any problems further on, because the other thing is that you can actually induce an infection on the sow when you're giving the birth assistance. So we really would like to minimize this birth assistance. So the major problem for the sow, which when they come to the farrowing, is they are not eating while they are farrowing. At least most don't. And at the end of farrowing, some sows has not been eating for 20 hours. So if they are already weak when they start to farrow, they are not able to raise up, and they are not really able to speed up the process, simply because they are being depleted of energy. So it's difficult to help the sow in that position. She is captured in a situation where she can't really do much about it. So there are some potential solutions as we see it. We can give the sow more meals per day, we can give her more feed per day, or we can give her more fiber per day, because the latter will contribute with extra energy for at least 24 hours. Some years ago we made a study, and at that time we recommended in Denmark to reduce the feed intake or to the feed supply 3 days before parturition. And when we do that, we also, of course, reduce the fiber intake of the sows. And at that time, we believed, well, if we can close this gap of less or insufficient amount of fiber, we can probably have the sows to farrow better. So we made a study where we added one group of sows this protocol, and another group of sows where we closed this gap. So we didn't want to go below 500 grams of fiber on a daily basis. And what did we see? We saw that the control group had 8.7 stillborn piglets on average, and if we supplied extra fiber, we could reduce that to 6.6, so 2% units roughly, less mortality, and it was very significantly so, and I should say we had 300 sows roughly per treatment here. We actually were also interested in the pre-weaning mortality of the piglets, because we wanted to improve the colostrum production in this trial. We didn't improve it statistically, but numerically it was also better giving them fibers, and total mortality was reduced by 2.4% units, also highly statistically significant. So fiber are really good. Now I'll show you a slide from a Finnish study. They have made a very nice constipation score scale, and they have also been looking into whether the constipation or whether the feces consistency has any relationship with the farrowing. And it was realized 10 years ago that yes, there is some relationship, maybe not very strong relationship, but clearly the more soft feces, the lower farrowing length. And this is, it can be due to physical blockage of the birth canal, which was suggested by the Finnish people, and I believe this is part of the explanation for sure. But I would also say soft feces is clearly indicating also that they have got more fiber. So when they get more fiber, they also take up more energy many hours after they have been feeding. So probably a higher uptake of short chain fatty acids in this area here as well. So I guess it's two sides of the same story. We have two things. We have energy depletion is a problem, and we also have physical blockage of the birth canal being a problem. So last year we started our new project on this issue, Born to Live project, where we have 3 work packages, and today we have run all. We've just completed the number 3 work package, but we have tons of data, and we have started doing a lot of analysis and so on, and now we are starting up writing the scientific manuscript from work package 1, and that is what I'm going to present to you today. So we expected that by increasing the feed intake from 2 feed units per day up to 5.5 feed units per day, and I should say 1 feed unit is roughly 1 kilo So almost 2 kilogram per day up to 5.5 kilogram per day. And then we wanted to see what is the optimum, meaning the lowest response here when we talk about the farrowing problems. Farrowing problems can be farrowing duration, it could be birth intervals, it could be farrowing assistance, and it could be stillbirth rate. And we expect that if sows are fed to low amount of energy, they will be energy depleted, which will prolong the farrowing. And if we feed them too much over here, we would have prolonged farrowings because we have physical blockage of the birth canal. The more fiber we feed, the more undigested material we also have in the hindgut. And if you have given birth assistance to a sow, you can easily feel if she's constipated. So if we fill up her hindgut with undigested fibers, we may also see a problem there. So this was our expectation. And we wanted to understand what is the optimal feed supply for sows when they come to the farrowing. This is the farrowing duration. Is in response to how many feed units or how many kilograms of feed per day, and we saw an optimum of 4.4 feed units per day. When we looked into the farrowing assistance, again we saw when they got insufficient amount of energy, they had a high amount of a high frequency of farrowing assistance, then it dropped, and then it increased again simply because we have, as we believe, a physical blockage of the birth canal. And what was the optimum? In this case, we found 3.9 feed units per day. We also looked into this to the number of stillborn, and this is a trait where we know we need a lot of sows to document any statistical difference, and we didn't see a significant effect here, but we did see the same trend, a decrease, and then it started to increase again. So I really believe that these data are sound and robust, and we could see that the optimum for this trait was 4.0 feed units per day. We've looked more into what happens really inside the sow. We want to understand what is the sow doing at different time points and in different organs. And we did some surgeries with sows to understand while the sow is farrowing, what is the uterus doing? We know the uterus is having uterine contractions, but what is the fuel? What is the energy coming from the diet and allowing the sow to make these strong uterine contractions? And I can tell they are really, really strong. What is it that is fueling this? And we could see when we looked into the arterial supply of blood and the venous drainage of blood from the uterus, we could see that there are 2 components in the blood that is being taken up by the uterus. while the sow is farrowing. First and mostly, she's taking up glucose coming from starch, and that's what I have been telling you. Starch is only coming from the GI tract the first 4 to 6 hours after the last meal. Well, then she has a buffer in the liver, which she can use to mobilize from if it's not already depleted. And I believe if it may be depleted before she actually starts to farrow, if she has been building nest for too long time. And she also needs to produce colostrum at this time point. So there's really a competition for the glucose at this stage. Then she's also taking up triglycerides, and that was quite a surprise for us. Why is she taking up triglycerides? Why don't she take up the NEFA? Because if we are lacking energy, we would mobilize fat from the body. That will come as NEFA, and she can easily take up NEFA to the uterus, but she is not doing that. She takes up a way larger molecule. Triglyceride consists of 3 NEFA bound to 1 glycerol molecule. And to me, this clearly indicates the sow uterus takes up triglyceride because the uterus need the glycerol. Glycerol can be used as a precursor for glucose. If they lack glucose, they can use the glycerol instead. And that is probably the reason why she takes up triglycerides and not the NEFA. Interestingly to us was it that the sow is not taking up any short-chain fatty acids to the uterus. We actually believe, because we realized the sow has less stillborn piglets when she is fed more fiber. So we actually believe the uterus was taking up the short-chain fatty acids and using that as a fuel while she is farrowing, but she's not doing that. So it must be somewhere else in the body that the short-chain fatty acids are being used and making sure that more glucose can be used by the uterus. I'll come back to that because I have a hypothesis here, which we are working on. We could also see that lactate is not taking up. Actually, lactate is released by the hard-working uterus, which indicate that the uterus is actually also lacking oxygen. What could we else see from these sows with the catheters? Well, we could see that if we just look at the plasma glucose level in the sow at 1 hour after she started to farrow, when we plotted that, we could see when she started too late after the last meal, her plasma glucose was clearly compromised. We only had 10 sows in this case, but we could document that there was a linear decrease in this, and we could also see that it seems like the high fiber diet seems to be ameliorating these challenges a bit for the sow. And I should tell here, the sows that has not been eating for 9 hours, when they started to eat, that means they were really, really low in energy. They only had 2 millimole per liter of glucose in the plasma at the start of the farrowing, and that signals they are really, really weak. Normally, we would like to have plasma glucose levels of around 4, and 2, I would say we have a sow which is more dead than alive. The problem is we can't realize it when they are so weak. So I regard the farrowing of a sow is comparable to run a marathon for a human. It takes roughly 4 hours if you are not really athletic. And the trick is you have to complete the marathon before your plasma glucose become critically low. And 2 millimoles of liter is really critically low, both for humans and for sows. Now I'll change to colostrum. This is from a French study, a nice study where they demonstrated if piglets are not ingesting enough colostrum, their their risk of dying is really dramatically high. And then piglets, when they ingest more and more colostrum, the risk of dying is decreasing until a fairly low level here. So we have been working on not much on colostrum intake, more on the colostrum yield of the sow, because we know with the hyperprolific sows we have, the sow is the limiting factor of the colostrum intake of the piglets. So if we can have the sow to produce more colostrum, there will be a better chance for all the piglets to survive. And we have realized if we feed sows with some kind of fiber throughout gestation, actually from mating until they are transferred into the farrowing unit, then we can see that sugar beet pulp and pectin residue is really good for the weight gain in the colostrum period. But if we instead used potato pulp, which is another fiber source, that was really bad for the colostrum production. So we don't understand why are some of the fiber sources really good and why are some, or at least potato pulp, really bad. And we compared this to a low fiber control diet, which gave 96. And that's pretty interesting because we always end up around 85 to 95 gram in weight gain for the control diets when we have around 17% of fiber. So it seems like we have something we can repeat. And then we did a follow-up study where we wanted to go closer to the farrowing and give sows more fiber and less dramatic increase in fiber, so only 20% fiber now, and the last 10 days of pasteurization. We didn't see any statistical increase. We saw a numerical increase with the sugar beet pulp, but not a statistical increase. And the last study here with the fiber, that is from a French study where they compared a mix of fiber from sugar beet pulp, sunflower hulls, and soybean hulls, and they didn't see any improvement when comparing to the low fiber control diet. So it seems like some fiber can do some improvements, but it's not all fibers, and still we are not really understanding when should we feed more fibers to the sows. The experiment I talked about before, where we put in catheters in the sows while the sow were farrowing, we also had catheters in the mammary gland to take blood samples, and we actually also measured the blood flow to the mammary gland. And the purpose of this was to understand when is this colostrum actually being produced. We thought some years ago that, well, all the colostrum, more or less, is produced when the sow starts to farrow. And with this experiment here, we have documented this is not happening the way we thought. Actually, most of the colostrum is being produced after the first piglet is born. And that really changes our way of thinking of colostrum now. How did we realize that? Well, you can see here on top, this is what is taking up of nutrients from the blood to the mammary gland during the colostrum period, in terms of glucose, lactate, triglyceride. Below, you can see what is leaving the mammary gland. That is some carbon dioxide, some lactose, some carbon dioxide, some fat, and the yellow is something we can't explain. Let me state it a bit more clear. What we believed before we did this experiment was we would hardly see any uptake here as compared with the amount of carbon or energy being released as colostrum. We thought most was actually produced before. That means above here we would see not much, and below here we would see clearly a lot. But what we saw was there was really a 1-to-1 ratio between the uptake and the excretion or secretion. So we can conclude here that colostrum is mainly produced after the firstborn piglet. Of course, you can squeeze a bit of colostrum out of the mammary glands just before they are farrowing, but it's not much compared to the big amount of colostrum that is actually being produced. What we also saw is if we feed the sows fiber, we could see clearly some energy here, which we cannot account for. And this to me indicate that the sow has built up some fat in the mammary gland, which is being released as fat in the colostrum, but it was produced before the sow started to give birth to the piglets. And this is probably one of the good things with the fibers, that we do see some buildup of mammary fat in the mammary glands, and that can be released into the colostrum or maybe in the transient milk and increase the amount of energy being transferred to the piglets. And the good thing is it doesn't take any glucose while the sow is farrowing, because there's really a fight for the glucose while the sow is farrowing. So what happens with the short chain fatty acids coming from the hindgut? This is the blue one here. I hope you can see it. If we talk about a sow in early and mid gestation, that short chain fatty acid will come into the blood, be circulated, and eventually end up being incorporated into the back fat, because the sow is retaining back fat during gestation. But if we look at the sow in late gestation here, what happens with the same molecule in the blood coming from fibers? It is circulated with the blood, and then it is taken up to the mammary gland instead. So here it's actually retained inside the mammary gland in late gestation, and then it becomes released into the colostrum and in transient milk shortly after the farrowing. So just to summarize here, what is needed for the sow when she comes to farrow? Clearly energy, and energy is a lot glucose. It's needed for the nest building activity. It's needed for the farrowing, the uterine contractions, and it's needed for the colostrum production as well. Remember that glucose is really the precursor for lactose. It takes two molecules of glucose to make one molecule of lactose. But if you consider fat, it takes a lot more glucose, 13 times more glucose than one molecule of fat. And the thing is, we have to make the glycerol, and we also have to make chain elongations of the free fatty acids before it's converted into a triglyceride molecule. So if we can, by fiber, spare some of the fat synthesis while the sow is farrowing, I think we have a really good way of helping the sow over the farrowing. So to me, fiber in feed is really, really good. It can help the sow to prioritize glucose needed for the uterine contractions and needed for the production of lactose. And especially lactose is really important for the yield. We have looked into this in one of our experiments, and we can see then when we feed extra fiber to sows before parturition, we can increase the fat concentration in the colostrum by the fiber to 7.4% in the colostrum. And if we use the control diet, we only have 5.0% of fat. So it seems like we have some mechanism going on here, as I have been illustrating to you. And if I should conclude here on this and give a bit of hints, I would say sows, they risk being depleted of energy during the farrowing. We recommend now to use 3 daily meals before farrowing, simply to avoid energy depletion. If farmers want to give fibers as a manual extra supplement, it can be done pretty easily, because they only need the extra fiber supplied once a day, so it can be given as a supplement maybe in the morning or in the afternoon, just once daily. So it's fairly easy to do, even though you have another automatic feeding system. But it really depends on your feeding systems, whether you should do more or less manual feedings. Colostrum, we have realized it's mainly produced after the first piglet is born, especially if we look into the lactose production and also the fat being secreted in the colostrum. So fiber, if we feed more fiber to the sow, some of the colostral fat is being produced before parturition, which really helps the sow. And earlier on, we have recommended to reduce the feed supply to sows, so it would kind of help the sow over the farrowing. Now we don't recommend that any longer. We actually recommend to supply as much as 3.6 to 4.0 feed units per day. And I would say if you really have to get the maximal performance of the sow, you should use 4 feed units per day before parturition. But if you want to do that, you have to understand that you can't feed so much if you don't do something to dilute your nutrients, because colostrum yield in our study, it was actually maximized at 3.3 feed units per day. And that's because colostrum yield is most likely maximized depending on the ratio between protein and energy. And if we want to have the maximal performance, we should give them 4 feed units per day to maximize the farrowing performance, and then we can increase this one by lowering the amount of protein in the diet. So we have somehow to dilute the lactation diet to the farrowing sow or just before farrowing, because she's not performing well if she gets too much protein. Excess protein is actually a problem if we talk about the energy utilization. So it can cause another problem if we overfeed them with protein. So just to conclude a bit on the fibers, because they are really beneficial, especially during gestation and around farrowing. I would say it reduces constipation, it reduces farrowing length, stillbirth rate, total piglet mortality. Some fibers may increase colostrum yield and colostrum intake of the piglets. It can increase piglet vitality. Health of sows, especially stomach ulcers, are well known, but also other health problems seems to be improved by extra fibers. We can improve welfare and comfort, for instance, the nest building material, and we can reduce physical activity and therefore the total heat production of the sow. And finally, we can improve the satiety of the sow during gestation, where they are really keen on eating more. There are 2 drawbacks of fibers, especially if we want to include a higher fiber level in the lactation diet. The one drawback is that we see a lower feed intake at peak lactation, simply because the gastrointestinal tract becomes a limiting factor. It is also a problem in hot summers, for instance, or in tropical regions, because the fiber contribute with more heat from the internal organs. And then the other problem is that when we increase more fiber or add more fiber to the diet, we also reduce the digestibility of the feed. I haven't been talking about that today, but we can add silanase to reduce this problem. So there are different possibilities, and overall I would say dietary fibers are really, really good for the sows, especially around parturition. And with that, I would say thank you very much for your attention.
Some interesting question for you. You said that late gestation feeding of the fiber compared to the overall gestation feeding has a bit efficacy differences. So, but in another slide you said that okay, so late gestation feeding can also move the short chain fatty acid directly to the udder, so mammary gland. So what is the difference? Like why the efficacy? If I start to feed the sow like during the transition feeding, like what might be the differences, like in mechanism?
Physiologically, I believe that the sow know where to distribute the different things. In early and mid gestation, the sow knows, well, back fat is needed. I need to put on some back fat, but you can also say it's you don't have any colostrum production at that time, so it cannot take up a lot of short chain fatty acids up to the mammary gland. As the gestation progresses, more and more energy and focus of the animal is being devoted to the reproductive organs, and for the mammary gland, it's more and more important that the mammary gland are growing and that colostrum is being kind of the udder is primed to make the colostrum. So we can see that 1 month before farrowing that some of the colostrum components starts to be produced in small amounts. It's not because they are needed at that time, but I think it's the machinery in the mammary glands that starts to accelerate some processes and start to make sure, okay, this is working, and it's you can't change an engine from 0 to 100 over a moment. You need to kind of work to heat up in a way. That's how I understand the physiology.
And I have a concern, like, okay, sugar beet pulp is more abundant in our Europe. So let's see some part of the Asia or even America, like people have been listening to us. I mean, sugar beet pulp is not available. So what kind of like physical and chemical properties do you think we have to consider in selecting the fiber and getting the same piglet quality? So you have any recommendation?
I wish we had more knowledge on the fibers in terms of sow performance. We're working on it at the moment. We have this nice project, Born to Live, as I was talking about. So we are looking at 4 different fiber sources at the moment. One is sugar beet pulp, one is soybean hulls, one is palm cake, and one is a mix of different components. One of the components is resin acid. We have found what we believe are the best components and added that into a mixture, and I hope to get some really positive responses from the sows in that experiment, but we haven't analyzed the data yet. But I would say, what are fibers? It's really difficult because chemically we can easily distinguish them between soluble and insoluble fiber. That doesn't tell us much about whether the sows are performing well or not performing well. We can I think a better thing in terms of the farrowing process would be to really understand how fermentable are the fibers. There are some in vitro methods to understand that, which will help us from where we are now. But to me, it's really the colostrum production that is the most limiting thing for the performance of the piglets and the sows. And I think one of the problems with the fibers are that fibers is not only short chain fatty acids. We have a lot of different metabolites coming into the blood when we ferment fibers and take up a lot of bioactive components. Some of them have hormonal actions, and I guess that is what we need to understand from where we are today. I have seen some chromatograms from mass spec analysis, and we can see more than 1,000 of different metabolites if we consume sugar beet or if we consume another fiber source. So it's clearly not only short chain fatty acids coming into the blood, and I think that is what we need to understand where we are now. What are the components coming into the blood that may give a high colostrum production, and in some cases, and a bad colostrum production in other cases?
Thank you, Peter. And I have still a lot of interesting questions, and I myself have even A lot of questions on my mind, but of course I can go back to you later on. And also for the audience, let us know later on if you have some still question left. But at the end, we will move to our third presentation of today's webinar by Dr. Claudio Oliviero. Dr. Claudio is an adjunct professor at Department of Production Animal Medicine, University of Helsinki, Finland. Dr. Claudio's research mainly focuses on neonatal piglet survivability by farrowing and lactation management and optimizing post-weaning growth of the piglets. He has been successfully implemented some strategically important projects of the Finnish government on antibiotic reduction, especially in neonatal piglets. His piglet management strategy has been widely following in Finnish pig production. Dr. Claudio is giving a presentation on challenges of large litter and their management.
Thank you, first of all, for inviting me here. It's a good opportunity for our research group to show also our studies to everybody here present, and it's really a pleasure to have listened to Filip and Peter presentations. So today I will describe in a short time, unfortunately, but that's how this webinar are working. So I will try to focus on the challenges we have nowadays with these hyperprolific sows, and how we can manage those animals better for better production. I have a problem with the presentation. Okay, now it's changed. So here, just for the ones that are not very familiar with these hyperprolific sow lines, I mean, what does it mean? It means that we have basically sows that produce a lot of piglets, and much more than their physiological, possibility are. You can see from this slide, for example, I picked up 2 countries, so Denmark and Finland, because it's quite nice to see this development during the year. So as soon as Denmark started to work on hyperprolific sows, so the number of piglets per sow born increased dramatically during the course of the years. And the same applies to Finland. You see, in the beginning they were more or less at the same level, and then as soon as Finland started to also adopt this genetic lines in the production, we saw the similar trend. So, and this is very often happening quite fast when you adopt this kind of genetic line in your production. Another important thing that is connected with large litter size, so these hyperprolific sows, it's interesting that when you have more piglet born, of course, duration of farrowing also increase accordingly. And this is a sort of summary study that we have done a couple of years ago, looking into some studies published in the recent years. And you can see that when you have increase in litter size, you have also increase in duration of farrowing. It's quite linear correlation. And so now, if we look a little bit into the physiology of the farrowing process, so why this farrowing process is important. Because first of all, we need to go a few hours before farrowing, when we have this nest building behavior. Peter has already introduced this to you. For the ones that are not familiar, this is an innate behavior that the sows have. So whatever environment of sow will be into, she will try to perform this nest building behavior. Of course, in natural condition, this is possible to perform in, I would say, in the best of the way. But as Peter already showed you, when there is no possibility to perform this, the sow will anyway try to show up this behavior, and it will drive this attention towards the environment, so the cage, bar, or the floor, and so on. Interestingly, I have a video here, I don't know if it it doesn't seem to work, unfortunately. Well, don't know why this is looking different, but well, it was a video here that was trying to show you how this nest building behavior is. But let's just talk now why this nest building behavior happens. Well, it is known that nest building behavior is hormonally driven. Okay, so some hormones are driving this behavior, and the two that are involved are progesterone and prolactin. As you can see here in this graph, when farrowing happens at 0, just a couple of days before, we have a switch into the level of progesterone and prolactin. So we have a decrease in progesterone and an increase in prolactin. So these two hormones are responsible of the nest building behavior. Interestingly, we have recently published these results where we were looking into the 3 different kind of environment, completely different farrowing environment, I mean. And you can see here on the right a pretty standard farrowing crate where the sow is allocated in a crate and basically on half concrete and half slatted floor, with basically no nesting material, nothing that the sow can use in order to fulfill this nest building behavior. Then we have an intermediate condition where the floor is provided with some sawdust, for example. And then we have an extremely opposite situation where the sow is in a free farrowing environment. So the sow is able to move free into this environment, out and inside, and it has plenty of nest building material. So in this case, it's straw. So you can see here the difference in progesterone level at the moment of farrowing. So when we know that progesterone should go down a certain level, you can see that in the herds with, I would say, the most poor environment for the sow, the level of progesterone were over the threshold that it's considered to be normal at farrowing. While when we go into a more mild environment, or even, I would say, more natural environment for the sow, the progesterone level is well above, below the normal level that should be. Interestingly, those two hormones, so progesterone and prolactin, which we know are involved in the nest building behavior, they are also involved in the colostrum production. So this is a French study which shows quite nicely why we have why the low colostrum production sow, so the sow that produce less amount of colostrum, are compared with sows that are producing a normal amount of colostrum. And you can see that there was found in this study sort of correlation between the level of progesterone and prolactin at farrowing. You can see here that the progesterone in the sow that are producing low amount of colostrum, the red one, it was higher if compared with the sow that produces a normal amount of colostrum. And the same applies opposite way to the prolactin. So the sow with low amount of colostrum produced, they showed a lower level of prolactin before farrowing compared to sow that had a normal production of colostrum. So it seems that there is really an intercorrelation between how the sow can perform a normal behavior and how she can produce also a decent amount of colostrum. Other studies has showed, and we have one very recently published, where we found a correlation between the longer duration of farrowing and lower production of colostrum. In this study, it was found that if you have a 100-minute longer duration of farrowing, you have a decrease of about 220 grams of colostrum production. The same study we had, if we plot all the sows in the study and we look to their colostrum yield, we can see that we have in this right side sows that are producing a decent amount of colostrum. The average litter size in this study was 16 piglets per sow. So we assume that 4,000 grams of colostrum are considered the minimum amount for fulfilling the piglet needs. And you can see that we have quite a big amount of sows that produce enough colostrum. Some are producing even quite over the requirement. But then if we look to the left side of this graph, we can see that there is also quite a lot of sows that are producing a level of colostrum which is much lower than what we expect. So colostrum, I don't want to belong too much into this, but Peter has already introduced you the importance of the energy of colostrum, the energy source for piglets. But colostrum is also immunity, and that's very important because piglets are born without a proper active immunity. They need to develop themselves, and it takes some time after birth. So that's why they are basically taking a passive immunity from colostrum, so IgG and IgA mainly, that are protecting the piglets for the time period that they need to develop their own immunity. If you look to this normal, I mean, at least in Europe, we wean about 4 weeks and of age, but I don't know, in other countries might be different, but if we wean at 4 weeks, this is just when the piglet are starting to, produce their own antibodies. So this is a really critical windows. So if you look to the normal happening in nature, so with wild pigs, the maternal passive immunity will last much longer because the wild piglet will be able to suck milk for longer period. In our study, this is reflecting what Peter has already showed you regarding the importance of colostrum on the survivability of the piglets. In this study, we were looking to the individual colostrum intake of over 1,600 piglets. And we looked at those piglets that were dying before weaning. Their average colostrum intake was about 200 grams. And while the ones that were surviving after weaning, their average colostrum intake was much higher. Sorry. I need to drink. So basically, in this study, we found that 31% of the sows produced insufficient colostrum for the actual litter size that was, as I told you, 16 piglets per sow. So we were expecting them to produce at least 4,000 grams of colostrum, but you can see that in these 6 herds that were involved into this study, some herds were performing very bad. And the same, of course, applies to the piglets. So 35% of the piglets received less than 250 grams of colostrum, which is considered the minimum requirement for each piglet. Colostrum is not only antibodies, as Peter said, it's also energy, and it also contains many other compounds that promote the gut, development. So the ability of the piglet to develop their gut in order to absorb nutrients. You can see from this study that when you have more colostrum intake at birth, you will be able also to grow faster. So 13.1 gram more of average daily growth if you are able to drink or intake 100 gram more of colostrum at birth. So this means that if you are able to give to your piglets 100 grams colostrum more, this will pay back to you at weaning with more than 300 grams of weight or higher for these piglets. So we have seen now the colostrum importance, but and how in this large litter the colostrum availability is reduced, unfortunately, for each piglet. But the problem is also connected with the size of the piglets in these hyperprolific sows litters. So you can see from this graph here that when you increase the litter size, so the number of piglet born per sow, automatically you have a decrease into the body weight, average body weight of this piglet when they are born. And you can see that if you take a hyperprolific sow of 18 piglets, which is not uncommon with these lines nowadays, their weight will be much lower than a standard, average of 12, 13 piglets liter size. So when we look to these things all together, so we have competition and crowding due to the larger litter size. We have lower birth weight. All these things combined together, we have lower colostrum intakes because of the low birth weight, but we have also competition which reduced the colostrum intake and it increased stress. So all these compounds can work together to, of course, reduce the intake of antibodies and energy, but also reduce the development of the intestine. And we know how this is important, not only for the nutrients that are absorbed by the piglet, but we know that in the intestine there is a lot of cells that are important for the immunity. So all this complex, situation will reduce the possibility for the piglet to develop a proper immunity. When we look to the situation of hyperprolific sows or large litters, of course, we have already discussed that if you are able to intake enough colostrum, you will have also higher level of immunoglobulin in your body, and then the piglet will be more protected. But that's, of course, connected with the competition between piglets. But we have also a sow compound here, which is, what about the sows that have more IgG in their blood and therefore they transfer more IgG into the colostrum? Is this good? Yes, it is good, because when you compare sows with higher level of IgG in colostrum and sows that have lower IgG in colostrum, you can see this reflecting exactly to the piglets. So piglets coming from these sows will have higher IgG into their blood compared to piglets that take colostrum from sows with lower IgG content. As Peter showed you already about the colostrum and how it is variable, it starts from the birth of the piglets, but then already about 6 hours after the birth, you have concentration of IgG into this colostrum, which is 50% less than in the beginning of the farrowing. So you see that there is a dramatic decrease into the amount of IgG only a few hours after the start of the birth. So it's obvious that if you are born earlier, you will be able to take the most of the IgG from the colostrum. If you are born later, which is not uncommon with this hyperprolific sow, we have duration of farrowing is over 7-8 hours nowadays. So if you born later, you will have, of course, a less, less IgG in the colostrum to intake. But that's not all. Now with this reduced size of piglets because of the large litter size, these piglets are less vital. And therefore, even if they are born very early in the start of farrowing, they are not capable to reach the udder because of their low vitality. They are too small and they are not, they don't have energy enough to walk to the udder. So this will take times before they are reaching the udder, and they will reach the udder when the quality of colostrum is very low. So summarizing a little bit what already also Peter was saying, nutritional feeding strategies are important to improve colostrum production, the vitality of the piglets, and also the farrowing process. There are several studies that demonstrated that different compounds can work in, for example, improving the colostrum production, or even speeding up the process of farrowing, or even giving you a higher level of immunoglobulin into the colostrum. But there are also other compounds which are important, like the environment, and which kind of environment we give to the sow in order to perform a normal breast building behavior and reduce the duration of farrowing. So, for example, allowing more space at farrowing will improve the conditions for the sow to have a shorter duration of farrowing. The same applies for nest building material. So straw or other kind of material that the sow can use will be important to promote the nest building behavior, promote the progesterone and prolactin ratio, and therefore also the duration of farrowing and colostrum production. And of course, as a last, I cite here the Peter Group's study that he has already described to you, so I don't spend too much time regarding the glucose level at farrowing time and the time of feeding to farrowing. When we look to the farm itself, we know that each farm is different. We have different conditions, we have different management, we have different breeds and so on. So it's important also to look where my farm is standing. Okay, it's not very easy when you want to look, for example, to EGG content of my sow colostrum. But nowadays there is something that it can be done. So I will show you in a few minutes. So this is just to show you, these are 11 farms that we had in a study a few years ago, and we were looking to the EGG level, and you can see how here that there is a huge difference between farms. And why this is happening? Well, I told you there are so many differences between farms that can affect this kind of situation. So what it can be done just to know on your farm level what is the condition. It could be to use this Brix refractometer, for example. We have developed a method where you can look and have an estimation of what could be the EGG level of the colostrum in your farm. And you can see in this table here, according to the results that you get, you can estimate if you have a good or not good colostrum quality. So summarizing this presentation, I would say that what are the measures that I would try to focus when I have these hyperprolific sows? I have too many piglets, and I have also piglets that are not vital at birth. Well, if possible, it could be very important to support the nest building behavior, because we have seen how important it is for the sow, but how important it is to balance those hormones that are responsible of the colostrum production and also the duration of farrowing. So if you can use straw, sawdust, paper, whatever it is, 5 to 10 liters, 1 or 2 days prior farrowing, it's enough. And of course, allowing more space where possible. So if you have a possibility to open the crate and have a pen where the sow can move, that would be also very profitable. Adequate fiber, I don't spend too much time here because Peter has given an excellent presentation on this, but fiber is very important and it should be added to the late pregnancy diet in at least 7 to 10% amount. The high fiber supports not only the energy level as we have seen, not only the nest building behavior, but it supports also the constipation, which we know it's a problem, and for sows at farrowing. So it's very important for that. And at the same time, water should be checked. So we should supply sows water enough when they are approaching to farrowing. So 4 liters per minute is the minimum water flow that we recommend. There are also targeting feed additives like yeast, resin, acid. We have seen something today about those things. And there are signs that this can improve, for example, the colostrum production and also the EGG content of the colostrum. And then also, if we look to the management with piglets, I would say that it's very important to focus in the first 6 hours after the start of birth. Those are the key hours when you can work with piglets in order to make them to uptake enough colostrum. So don't lose time with the management, try to act immediately after the starting of farrowing when it is possible. So thank you, that was my conclusion for this presentation.
Thank you very much, Claudio. Thank you for all this information. I will have a couple of questions to you as well. So quite often we say that sow is the main limiting factor for colostrum production, especially for this hyperprolific sow. So do you see that this ability to produce more colostrum, like very big amount of the colostrum, is driven by the genetics, or sow is like putting some milk inside, or piglet cannot suck it out, like when they are less vital?
Well, definitely there are differences between genetics. I'm not aware of which kind of this difference, but I know that there are differences, and it's difficult to say which breed is better and so on. But I think that the main question here is also that you need to provide the sow with the good tools to produce colostrum. So all the things that we described before, you need to give it to the sow. And then you need to have piglets that are vital enough to stimulate the udder. Those are the key compounds to get a good yield of colostrum.
And when it comes to the question of like say immunity, we quite often say like immunoglobulin G. So I guess like what I know, like 80% in the colostrum is like protein or immunoglobulin G at the beginning. So do you see the importance of like other immunoglobulin at the beginning, like IgM or IgA?
Well, IgA for sure, they are very important, and they will be important for the all lactation because those are produced continuously from the sow also after the colostrum production. And the IgA are important, we know, for the local immunity in piglets, so the intestinal immunity. So that definitely, yes, IgA are also very important. But IgG plays a very important role because they are stored in the piglet blood for many days, and I would say weeks. And it will, they will protect the piglets for specific, pathogens for longer time. Okay, IgA are very important for the local immunity.
Okay, thank you very much, and dear audience. Now I will continue with a very short presentation introducing you the Hankkija finished feed innovations, latest innovation, this Progres, the resin acid-based product, and its application and benefits in sow or piglet production. So Progres is an innovative feed ingredients from Finland, and it is completely natural and derived from forest industry byproduct. What is inside Progres? It has an active ingredient. We call it resin acid, what you have seen from the first presentation, and with a blend of different free fatty acid. It comes from the thermal distillation of the crude Theil oil, a byproduct from the cellulose process. The fatty acid portion is around 90% and mostly comprises linoleic acid, oleic acid, conjugated linoleic acid, and phenolic acid. And this 9% resin acid is mostly abiotic acid and dihydrobiotic acid. We have tested Progres in different field and research trials and published in different scientific journals and conferences. Progres application shows similar and constant benefit in sow diet. Here is an overall summary of the benefit of the Progres application in sow lactation diet. It reduces farrowing duration and number of stillborn piglet. It improves the colostrum production in sow and also colostrum intake by piglet. Progres in the sow diet also improved the immunoglobulin G content and also an acute phase proteins called serum amyloid. Progres in sow diet also reduces the pre-weaning mortality and also heavier piglet from the Progres feed sow at weaning. You already know that sow litter size has been increasing constantly. This can create sometimes huge problem in the farm management, especially at farrowing. Piglet need to consume enough colostrum to gain energy and boost the passive immunity. Even though with full potential, sometimes sow doesn't produce sufficient amount of colostrum for her litter. This is again from the Claudio's slide, but it's in a different presentation. You can see that those piglets die before weaning. They have a very significantly lower amount of the colostrum intake compared to those are alive at weaning. And not only the survivability, but also weight gaining. You can see from this first graph that weight gaining is also depend on the amount of the colostrum they get at farrowing. And this is the calculation that Claudio said that 100 grams of extra colostrum can give 13.1 gram of average daily gain, and piglet can be 366 gram extra heavier at weaning. So based on those things, we have we did this trials. This trial was conducted in 3 different herd in different countries. 2 trial was in Finland and 1 in the Netherlands, and we have published this result already in the Journal of Animal. And dose of the Progres 1.5 gram, that means per kilo of the feed, and we fed the sows only for the last week, that means during the transition time, last week of the pregnancy before the farrowing. What we have seen, we have measured the colostrum production of the sow. We measure all the body weight of the piglets immediately after the birth and at 24 hours after the birth of the first piglet. And we calculate the colostrum intake of individual piglet by a formula. And out of 3 herds, you can see that 2 herds has a Progres feed sow had a significantly improvement in the colostrum production. We collected the colostrum samples as well from the sow within 0 to 2 hours after the start of the farrowing. And we measured the colostrum concentration of the immunoglobulin G by ELISA assay. Feeding Progres shows a constant improvement of the IgG in the sow colostrum in all 3 trials. We also measured this serum amyloid A. This is an acute phase protein, and we found that Progres fed sows has also a improvement in this serum amyloid A concentration in colostrum. So those who don't know this benefit of the serum amyloid A, this is an acute phase protein, and it is beneficial especially at the neonatal in different neonatal species. This acute phase peptide can stimulate the intestinal epithelial cells to produce mucus and bind the pathogenic bacteria and prevent diarrhea. In those same trials or same herd, we measure also we followed the piglets until the weaning and found that piglets from the Progres feed sows were heavier at the weaning in 2 trials. We repeated the trials again also in different trials in Pavlovice Research Institute in Poland. This trial was not in the hyperprolific but rather on a local breed, and we have seen as well this significantly lower mortality and also improvement of the in the number of the weaned piglets. And you can see this was not statistically significant, but almost close to 1 piglet wean extra. Our recommendation for application in the sow diet is you can start 1 week earlier of expected farrowing date, and then continue throughout the lactation. And recommended dose is 1 to 1.5 gram per kg of the feed. And thank you very much. I can see some questions. Some questions is really on the information about the Progres, but I would suggest you to contact with the respective area sales manager of your area. And thank you very much, and thank you Peter and Claudio for joining in today's webinar, and we are really grateful to having you. And also a big thank for Vadim for organizing this and also taking care of all this technical aspect of this webinar. And thank you very much to the audience also joining in this webinar, and I hope you all enjoyed it.